Welcome back to the course on blockchain. So, in the last class we have looked into a little details about the basic Bitcoin transactions and how we make a transaction of certain Bitcoin from one account that is characterized by a address. So, from one Bitcoin address to another Bitcoin address. Now, in this particular lecture, we will look into the details of the concept of Bitcoin script. So, during the last lecture, we have looked into this kind of fourth programming language based on which the Bitcoin scripts are designed. So, we will look more details about this Bitcoin script. So, as we are mentioning that the transactions in a Bitcoin can be characterized by the inputs and the corresponding outputs. So, it is like that the amount of Bitcoins which are being transferred from one user to another. So, you can represent the Bitcoin transactions in the form of series of inputs and outputs. So, it is like that one user, the Alice, she has received some 100 Bitcoins. So, once Alice has received this 100 Bitcoins, out of this 100 Bitcoins, Alice sends say 40 Bitcoins to Bob and some 60 Bitcoins to Charlie. So, in that case, this particular transaction has one input which is coming to Alice from someone else and has two output. One output is going to the input of Bob and another output is going as the input of say Charlie. Now, once Bob get this 40 Bitcoin, from this 40 Bitcoin, Bob can spend 30 Bitcoin out of those 40 Bitcoin to some say fourth person, say some delta with 30 Bitcoin and the 10 Bitcoin are still with Bob. And then this 30 Bitcoin they can be spent in one output at 10 Bitcoin, another output at as another 10 Bitcoin, and Charlie he had received some 60 Bitcoin. Out of the 60 Bitcoins, he can spend some 50 Bitcoin in a transaction. So, that way the Bitcoins that are generated in the network, the Bitcoin moves through multiple parties with these different transactions which are happening. And every transaction that we have mentioned, that can be characterized by one output and the corresponding input. Then this output of a transaction is like someone is sending that particular Bitcoin and the input is that someone is receiving that Bitcoin, and with the help of the Bitcoin script we want to actually ensure that this particular input corresponds to this particular output. So, let us see that how Bitcoin script works. So, explaining the Bitcoin script would be easier if we go with an example. So, let us go with an example that Alice wants to make a certain transaction to Bob. So, Alice initiates a transaction, that transaction contains the address of Alice and Bob with say certain amount. So, the amount I have not written here, say the amount can be something like say 10 Bitcoins. So, Alice wants to make a transaction of 10 Bitcoins to Bob, and this A and B corresponds to the addresses, and as we know these addresses comes from the hash value of the corresponding public addresses. Now, the question is that how Bob will verify that the transaction actually originated from Alice. So, if the transaction actually originated from Alice and this is not a forced transaction, then Bob can spend this 10 Bitcoin into another transaction. So, what we generally do that we have mentioned several times earlier, like with the transaction we include two other parameters. One is the public key of Alice. So, this is the public key of Alice, and we also include the signature from Alice. So, these two things are included in the transaction. Now, as we know based on the digital signature mechanism that only Alice can have her private key. So, Alice has her private key, and with this private key she has generated this particular signature, and if the public keys of Alice is available, using this public key you can verify the signature. So, Bob can verify this signature and Bob can be sure that this transaction has actually originated from Alice and that is a valid transaction. So, in that case the Bob's wallet can consider that whatever amount, so earlier it was some 10 Bitcoin, the 10 Bitcoin amount that has been transferred. So, Bob can certainly take these 10 Bitcoins and use that 10 Bitcoins for another transaction. Now, what Bitcoin actually does, that instead of sending this individual public key and corresponding signature, Bitcoin actually transfers some scripts. So, what are those scripts? So, traditionally Bitcoin uses two scripts, one is corresponds to the signature, which we call as the script seek, and another script corresponds to the public key, that is the script public key. So, this script public key basically tells you that how you can use the pub key to validate the corresponding signature. So, this Bitcoin script, in general it is a simple programming language which is compact, a stack based language which is processed from left to right. So, from left operator or operand you can start processing it, and then you can proceed further in the right, and it is a kind of forth like language. So, it was inspired from forth, and based on that forth language the basic Bitcoin script has designed. But the interesting fact of Bitcoin script is that it is not Turing complete. It means like it does not support all the operations, like it does not support a loop kind of operation, and it was intentionally made simple so that people can write down some simple scripts and the scripts can be validated, and it also makes difficult to write down some kind of attack scripts. And because this particular scripting language is not Turing complete, by Turing completeness we mean that it supports any of the language that can be accepted by a Turing machine, because we do not have this concept of loops and few other complicated things. This particular scripting language was not traditionally Turing complete, but recently the Bitcoin developers, they are including new features in the script and they are planning to make it Turing complete language. But keeping that side apart, intentionally the language is very simple, and as it is not a Turing complete language, you do not have the kind of halting problem. So, it does not have the loop. So, you do not have a problem of infinite loop inside your language. So, in case of Bitcoin script, so with every transaction Alice must provide a public key. So, this public key, whenever you are making a hashing over that public key, it yields the address of Alice, which is embedded inside the key, inside the script. That way you can validate that the transaction was actually originated from Alice, and then a signature, that signature verifies that the public key which has been transferred, that public key actually corresponds to Alice. So, the idea is very interesting. The idea is that you are making a transactions from say A to B, along with this transaction. So, Alice to Bob, along with that transactions you are putting a public key, say the public key of say the public key of Alice, and you are putting the signature of Alice which was generated using the private key of Alice. Now, what is the guarantee that the public key that you are getting, that public key actually belongs to Alice? So, what you can do, first of all, you can, using this public key, you can check the signature. If the signature matches, that means you actually know that this private key, what has been used for generating this particular transaction, it actually belongs to so this public key corresponds to the private key which was used to generate this signature. Now, as you know, this particular address was actually generated from this public key by applying some hash function. So, you can apply the same hash function over this public key, and you can see whether you are getting back this address or not. If you are getting back this address, that means that this was the original sender who had actually sent the transaction to you, and by doing this validation you are making sure that the transaction is actually authenticated and no one else in the future will be able to claim the transaction, and at the same time later on Alice will not able to deny about this particular transaction. Now, these things are actually embedded inside the script. So, let us look into this example script. So, as we have mentioned that we have the transaction input and the transaction output. So, at the transaction input we have the script seek, which contains the signature. So, this signature corresponds to so we have two component here. One, the first component is signature, it is the signature of Alice, and the second component is the public key. So, we have these components. So, we have the signature and the public key in the script SIG, and in script public key you have certain operation, and then you have the address of Alice. So, that hash function that the hash through which you are actually getting out the address. So, this address is embedded inside the script. Now, let us look into that how this script are actually executed, and using this script SIG and script pub key, how can you validate the authenticity of the transaction. So, this is a sample script. So, in the sample script you have two entries, you have the script pub key and the script SIG. So, in the script SIG you have the signature and the public key, and in script public key you have certain operations. So, while explaining the operation, I will actually explain you what is the meaning of all these different operations. So, as we have mentioned earlier that Bitcoin script is a fork-like of programming language. So, it is processed from left to right, and it is processed with the help of a stack. So, we will take a help of a stack and try to process this particular script. So, let us look into that how this script is being processed. So, initially the first task is that we need to combine these two scripts together. So, by combining these two scripts together, we get a combined script like this. So, first we put the input and then we put the output. So, the input script is your script SIG. So, first you put the script SIG, that means the SIG and the public key, and then you put your script pub key, that is the output script. So, the output script is written here. So, initially the stack is empty and you have generated this combined script by combining the input script and the output script. So, once you have done it, then let us process it using the similar concept of this reverse polish notation that we had used to process fork language. So, how will we process that? We have this initially SIG and pub key, which are the operand. So, if as these are the operand, we push that operand in the stack. So, after pushing the operand in the stack, initially the stack was empty, then we have pushed these two operand in the stack. Now, that is our resultant script after pushing these two operand in the stack. So, then we have this operator op_dup. So, what op_dup does? Op_dup, the dup operator, it actually makes a duplicate of the stack top value. So, earlier the stack to stop value was this pub key. So, on top of that pub key we have duplicated that things. So, another entry of that pub key is pushed into the stack by this op_dup operator. Then we have this operator op #160. So, what this #160 operator does? It applies this RIPEMD 160 hashing mechanism on top of the. So, it applies this RIPEMD 160 hashing mechanism on top of this pub key entry that was there at the top of the stack. So, by applying this hash, you are getting an operand like pub hash. So, after applying this operator, you got the pub hash and that is pushed inside the stack. Then at the next step, okay, at the next step you have the pub key hash. So, you this is a operand. So, you push the pub key hash in the stack top. Then you have the operator equal verify. So, this equal verify checks whether the two hash values which are there, whether they are equal or not. If they are equal, then you return true, you just simply popped it out, and if they are not equal, then you return a false or an error. So, this equality is checked between the top two items in the stack. So, if these two hashes are equal, then that means the ID that has been transferred in the transaction. So, whenever you have made transactions from A to B, you are actually verifying that this address corresponds to the address of Alice. So, once that thing is done, then The next operator is OP check sig. In the OP check sig operator, it again takes the 2 operand from the stack top, and after taking these 2 operand from the stack top, it verifies that whether the signature corresponds to this public key, whether that is a valid signature or not. So, you are doing a signature validation here. So, after doing a signature validation here, if you have validated that the signature is correct, that means you have validated that the signature is actually coming from Alice. So, in total, what you have basically done by executing the input script and the output script, by looking into the output script, you have found out that, well, Alice has actually made that particular transaction. So, the address which was there inside the transaction, that address corresponds to the address of Alice, and then by looking into the output script where there you had the signature and the public key, you have actually validated that that the signature corresponds to that particular public key. So, the signature is a valid signature of Alice. So, the combining this input script and the output script together, you have actually ensured that the transaction has originated from Alice itself and the transaction is a valid transaction. So, now once you have validated the transaction that the transaction is a valid transaction, then you can include that transaction, accept that transaction as a correct transaction, and whatever Bitcoin that has been transferred to Bob, Bob can start utilizing that amount of Bitcoin for other transactions. So, this Bitcoin script, it is a very intelligent mechanism to make such kind of checking that whether a particular transaction output, a transaction input, it corresponds to a transaction output or not. Now, in case of Bitcoin instruction, that was the earlier version of Bitcoin script, the initial version of Bitcoin script, it has a total of 256 different opcodes. Out of them 15 are currently disabled and 75 are deserved. So, you have different arithmetic operators, you have different if then conditions, then the logical operators, the data handling operators like obdup which duplicate the entries of a stack top. Then you have different kind of cryptographic operators like the hash functions, the signature verification operations, the concept of multi-signature verification operations where the signatures from multiple users are combined together and that multi-signature is used to verify the signature coming from a set of users. So, you have all those different kind of opcodes as a part of your Bitcoin script. So, here are some interesting Bitcoin scripts. So, the first Bitcoin script, it talk about that you are making some kind of transactions for a probably unspendable or prunable output. So, in the script pub key, immediately you are writing as OP return. So, whenever you are immediately writing as OP return, so it will immediately return from the stack top with a false operand. So, whenever it will return from the stack top with a false operand, then you are sure that this particular transaction, whatever Bitcoin that has been transferred as a part of these transactions, they are not usable Bitcoin. So, you cannot use that Bitcoins any further. Then the second interesting script is that anyone can spend output. It is like that whatever transactions you are making in the Bitcoin network, anyone in the network can use those Bitcoin. So, in that case, in the pub key, we have make it empty. So, you do not have any pub key information. In the script sig, it is always returning as true. So, whoever is going to validate that script, they will immediately get a true and they will be able to use that Bitcoin. So, without making any further validation. Then the third script, it is like we are trying to freeze the funds until a time in the future. So, in the script pub key, you have an expiry time. So, this expiry time specifies that till what time you will be able to, you will not be able to use that particular Bitcoin. So, this OP check time check lock time verify, this particular operator checks that whether the current time is more than the expiry time or not. If the current time is less than the expiry time, then immediately it will return this OP drop. That means it will return a false, and that particular Bitcoin will not become usable. So if this operator check lock time verify, if it finds out that well the current time is more than the expiry time, that means the time has been expired, then it will go to this next part of the operator, it will skip this OP drop, it will come to this normal validation script, which was OP do followed by OP #60, the pub key hash equal verify and check sec. The normal script it will execute, and the intended participant will be able to use that fund in future. So this particular script basically ensuring that the Bitcoin that has been transferred, that Bitcoin will remain unusable for certain amount of duration. It is like that you have transferred certain Bitcoin, but you do not want the user to be able to use that Bitcoin say for 3 days, that you can embed inside this kind of scripts. Well, next we come to the concept of Bitcoin peer-to-peer network. So, as we have discussed earlier that Bitcoin works on top of a peer-to-peer network architecture in a complete decentralized manner. So, this Bitcoin peer-to-peer network, it is ad hoc network with certain kind of random topology, and on top of that it runs the Bitcoin protocol using the well known TCP port 8333, and all nodes who are the users in that Bitcoin network, they are treated equally, and new nodes can join in the Bitcoin network anytime. And one interesting property of Bitcoin is that it is permissionless. So, to join in the Bitcoin network you do not need to verify yourself to some authentication server, that is not required. So, whenever you want to join in the Bitcoin network, you can simply open up your wallet, and after opening up your wallet you can immediately send a join message to join in the network and start doing your own transactions. Now, for the old nodes, if the old nodes are not responding, the old peers, if they are not responding for certain duration, in general it is for 3 hours, then they are automatically removed from the Bitcoin network. And those users, whenever they will open their wallet again and start participating in some transaction, they can join in that specific network. Now, let us look into that how you can implement joining in a Bitcoin peer-to-peer network. As we have seen that in a Bitcoin network, it is a kind of random topology of nodes, and the links that are there in between two nodes, those are kind of virtual link, or those are kind of overlay link. So, do not expect that there are kind of physical links between the two users, those are kind of virtual links or a kind of peer-to-peer link. That means we are considering if I have a link with say another user Alice. So, that means from myself to Alice, we are virtually considering each other as a neighbor. So, in such a kind of overlay network, whenever a new node comes and wants to join in the network, so there are certain nodes in the network which work as the seed node. So, the task of the seed node is to provide the initial information to the new nodes who are going to join in the network. So, whenever you are installing your Bitcoin applet, inside your Bitcoin applet, the address of those seed nodes are already there. So, whenever you are trying to join in the network, you send a message to one of the seed node that give me the peer addresses. So, in response, this seed node will send you a set of addresses whom you can consider as the peer. Now, among that set of addresses which has been returned by the seed node, you can select certain random number of nodes and you can create a kind of peering relationship with those particular nodes, and you can join in this overlay network. So, this means that whenever you have joined this overlay network, whatever information you are going to send in the network. So, as you already know that whenever you are making a new transaction, the new transactions are broadcasted in the network, or for the mining node, whenever the mining node has found out some new blocks, the new blocks are again broadcasted in the networks, and whenever you have done so, then you can broadcast those transactions or broadcast the new block information to your peer nodes. So, once you have joined in the network, the first task of a node is to get the most recent blockchain from your peer nodes and update your local copy of blockchain. So, that is again an interesting principle, like you may be offline for certain duration, and whenever you are offline, during that time maybe the blockchain has increased with the new transactions, and it will certainly happen. Whenever that has happened, then you are actually, after doing this joining procedure, you are asking your peers to give them the most recent or most updated blockchain information that they have. So once they are transferring the most recent blockchain information to you, you compare those blockchain. So here we apply some kind of 50% rules. Because of this principle of decentralization, it may sometime happen. So the details we will discuss later on. It may sometime happen that you are getting two different copies of blockchain from your neighbors. If you are getting two different copies of blockchain from your neighbors, you accept the copy of the blockchain which has been transferred to you by most number of peers. That means if certain copy of the blockchain has transferred to you by more than 50% of the nodes in your peer list, then you accept that particular copy of blockchain. And while accepting the blockchain copy, you also need to ensure that you are also considering the longest chain in the current blockchain. So once you have got the most recent copy of the blockchain, then you can start the transaction procedure. So that is all about today's lecture. So in the next lecture, we will look into the details about, after doing this joining procedure, how can you initiate a transaction and how that transaction gets propagated in the Bitcoin network. So see you again. Thank you.